How are you, everybody who is watching this fantastic video? My name is Olenjolaim Moko TAYAI single. Simply just call me Olenjolai. I'm a Tanzanian, and also I'm from Tanzania, it's of the African continent. I'm very happy to have, whether you're international or a national viewer, you're warmly welcome into this fantastic moment. God has prepared the good news through my lips. So I mean that get prepared to be transformed from your transformed, especially in your mindset, from one point to another point. But get also prepared to be trendy or to be taught in a fantastic way. We're using different teaching aids and different teaching methodologies in order to transfer the knowledge that I have and I've been preparing for you into your mind, and also to let you and to give you a challenge on how that you can solve the real life problems. So let's take this opportunity, whether you are a national or international viewer. When I say national, it means you're a Tanzanian or you're non-Tanzanian. You are all welcome into this fantastic moment, because the program we are doing, actually that we are using the curriculums in the syllabus of Tanzania, but the contents or the theme is internationally. Why? Because every concept that we are going to teach you in this system is universal. It's not just for the Tanzanians only, that maybe we've discovered our own content, so we have no. It's universal. And then you can find that it's actually meet demands of everybody around the world. So let's take this opportunity to welcome you into online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, I would also to welcome you into one of our YouTube channel that's called the Online Undergrad Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So, this is a good moment right now that there are so many questions that are going on in your mind. Let me just start asking questions. Possibly, you are the one who is watching this program right now, you are an undergraduate student, or either maybe you're expecting to be an undergraduate student, or either you might be a parent or a guardian or a sponsor who is taking care of undergraduate students. Well, first of all, I would like just to tell you that we'll be focusing on providing the contents essential, high advanced, and even high quality contents for the undergraduate students who are taking engineering and scientific programs. So here we won't be talking something about history, maybe about the Bachelor of Laws or College of Law. No, we are focusing on engineering and science. So if you are either of those two fields, then you're warmly welcome, because you'll get so many concepts that you have been looking for. Possibly, let me just ask you some questions. I know you've been asking yourself so many questions, but possibly you love so much engineering, mathematics, but unfortunately that you've encountered some problems or challenges along your way of learning. So you've been asking yourself that where can I go? Where can I learn the beauty of engineering mathematics for undergraduate? Well, the answer to that question is the place that you have to go is Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, where you can access all of its contents at any time and anywhere. Possibly you've been asking yourself so many questions that it seems I'm not going to do well in my continuous assessment of modules or courses of engineering mathematics or scientific mathematics. Possibly you've been asking yourself so many questions about how can I go around and how can I be prepared for my end of semester exams? How can I do it well? Because you have been attending the formal classes, but you don't understand. You have been asking your classmate to teach you, but you don't understand. So, my dear students, I would like just to tell you that all of those questions and even some other questions I didn't mention that going around in your mind, you can get answers in Online Undergraduate Polytechnic Institute of Tanzania. Do you know what the meaning of Polytechnic? So it means that here we are dealing with different technical issues in the mind of people that we have to pour out and solve real life. So well, now we have a problem that we are solving. I've been trying to state. We have also solution. We have a vision. We have mission. We have also plans. We have as the main objective, we have specific objectives. But let me just explain a few minutes to remind you about the vision that we have, because we know that you are the second year undergraduate students according to the course and the context that we are going to cover with you. The vision that we have an assignment we've been given by God Himself, that we would like you to teach and train some group of students who will be ready to extract knowledge and wisdom from the formal and informal engineering and scientific education, and combine that knowledge and wisdom with the knowledge and wisdom that we have to extract from the Word of God written in the Holy Bible in order to solve real life problems. So our main objective in online undergraduate Polytechnic Institute of Tanzania square bracket Olenjolaim is to see ourselves as teachers. We are solving real life problems like the one that now we are solving through teaching. We are solving a national real life problem. But it's not necessary for you also, maybe possible that you cannot solve a national or a regional or a city real life problems. You can start from your family, your own problems. You can solve even your own problems by using the skills and knowledge that you'll be acquiring throughout your process of learning. Well, so even also our main objective to see our students real that thinking differently, and also their real thinking about how they can solve real life problems that exist in the community by using the knowledge and the wisdom that we are going to extract in this program. So that's what we have to, that's the vision that we have in our mind, and should dwell in the mind of everybody. Okay, so don't worry about your continuous assessment. One of our specific objectives is to equip all our students with everything that they need, or the skills that they need in order for them to become victorious and to pass their continuous assessment. And also we have another specific objective which possibly that trouble in your mind, because we have experienced many undergraduate students in Tanzania. They used to abscond or to have discontinuous, or they used to discontinue, or to have so many supplementary in the modules or courses of engineering mathematics and scientific mathematics. So, well, not the challenge, not the problem. So here we'll be providing, or we'll be giving you a solutions in order to overcome all of those problems that you've been encountering around. But remember that I, Olenjolai, I don't know everything about engineering mathematics and scientific mathematics. I just know small portions of it. But I'm ready to share with you, and I'm ready to teach others what I know about engineering mathematics. So we are in our online undergraduate Polytechnic Institute of Tanzania, and then we have one of our YouTube channels. We have one of departments that's called Higher Engineering and Scientific Mathematics. This is one of the departments. We have also another department that's called Kingdoms of Heaven, where we are teaching you wisdoms and knowledge of the Word of God. You should visit also the playlist in our YouTube, because we used to organize all of these contents in YouTube under the single playlist. So every department has its own playlist. Every course has its own playlist where we collect all the sessions or all the sessions and put them together. So once that you want to enjoy them, so you enjoy from the beginning to the end. Stay tuned. Again, so we have so in these departments of high engineering and scientific mathematics, we have how many modules? We are teaching you 12 courses, or 12 modules, which actual that they will give you all the concepts that you have to cover, or covered by undergraduate students, especially in the African institutions and African universities, and even some of the European institutions, except some of the institutions and that actually they're learning in different ways, or they're going into too much detail. But we are going to cover almost everything that undergraduate students is acquiring in engineering and scientific mathematics. So today we are in Calculus 2, and these modules will be teaching according to the syllabus of University of Udom, so Udom. So we are in chapter 1, that's called infinite sequence. And this is lecture 3 that is stated as limit of the sequence and graphings of the sequence. And this at Udom, this module or course is being taught to the second year students in the first semester. I don't know about in your institutions or in your college or in your university. Don't worry about the name. Possibly in your institutions, you call these models or this course the different name compared to what how we call it at University of Udom. Well, so before we start our lecture series, I would like just to do the quick review of what? Quick review of lecture 2. So the quick review of lecture 2. In lecture 2, basically, we define first of all, we gave you the definition. First of all, we shared with you about the big picture again. Big picture of what? Of maths. Okay, from the nursery to the undergraduate level. And also, we defined sequence. Provided definition of what? Of sequence. Because the topic is called the finite sequence. So you have finite and finite sequence. But again, we taught you about notation of sequence. We said that a sequence contains, the sequence is actually that contains sorting, contains terms. These terms, they can be maybe A1, comma A2, comma A3, comma A4, comma A5, etc. Can be a sequence of letters or sequence of numbers and letters, a sequence of numbers. So that's all. And then I taught you about types of sequence. And then we found that we have two types of sequence. We have finite sequence, and also we have infinite sequence. Well, so that's what we've been discussing. But again, we say that you can find also the finite sequence can be expressed at the n stem, okay, as n stem at the infinite. We've been dealing with infinite. So infinite sequence, you say that the last term here it is infinite, and then you say it can be expressed in terms of what? In terms of the n stem. Okay, the sequence can be expressed in terms of the n stems. That's for example that we can have maybe n plus 1 over n minus 1. But here we say that we have, let's say from n is equal to 1 to infinite. So this is the n stem. Okay, first you come to indexing, last you come to index. So we've discussed so many information. If you missed it, don't worry about that, because that's the beauty of digital technology. The lecture and everything that I've taught, you can access it in our YouTube channels that called online and POLYINSTIT of TANZANIA, in square bracket OLENJOLAM. How can you access it? It is written as general introductions of infinite sequence. That's all. Or you can find the playlist of the calculus. You can go to the channels and then you find the playlist of calculus 2. All right. So I believe that, ladies and gentlemen, you are ready now, or you're ready now for me just to take you into today's concept. But I did one example, if you do remember, of finding few of the terms of the sequence. And as I left the homework, that's what homework 1. Did you do? And as I ask you that once you do, you send in the comment section. Did you do? If you didn't do, please do it and then send in the comment section. But let me start with that example to make corrections for you. So we say that this is correction of homework. But before you watch this part of corrections of homework 1, please I ask you, do the homework on your own or yourself before you check for this solution, right? Okay? I believe you're gonna do so. The question was asking, okay, write down the first few terms of each of the following of the sequence of the given sequence below. Okay, so the sequence, we are using the curly bracket notation, and then we have a numerator nth term, which is -1 power n plus 1 over, here in the denominator we have 2 power n, and then we have what? We have curly bracket, curly bracket, and here we have n is equal to 0 to infinite. Okay, that's the question that we left in to you. If you didn't note, so you can note and you can pause the video and then you can try. Write down the first few terms. There's no limitations, but just a few, right? So solution. Solution. So we say that the first term is n is equal to 1. So the first step, means you say the nth term. The nth term of the sequence, right? Nth term of the sequence is what? Negative 1 power n plus 1 over 2 power n. The first term is n is equal to 0. The last term is n is equal to, the first counting index is n is equal to 0. The last counting index is n is equal to infinity. So second step, we say that let us find the first term. The first term of what? The first term of the sequence. Okay, of the sequence. This we can find when n is equal to 0 because our sequence the first value of n for our sequence is n is equal to 0. So you have to substitute there. So if you substitute, we can have even these kinds of the bracket, but because we have other brackets like this, we say that negative 1 power n to 0 plus 1 over 2 power 0. And then this is when n is equal to 0, right? So what do we get? 0 plus 1, in the case of the exponent, is 1. So this will have negative 1 power 1 over 2 power 0, it's 1. So simply, this will make negative 1 over 1, right? So it means our first term, of the sequence is equal to what? Negative 1. We go again for the second step, ladies and gentlemen. Okay? For the second step, we say that let us find the second term. Find the second term of what? Of sequence. So to find the second terms of the sequence, this is when n is equal to 1. So when n is equal to 1, we say that here we have curly bracket. So here we have negative 1. Then we have 1 plus 1 divided by what? 2 power 1. Okay? So this one will be what? So it will be curly bracket, negative 1 square of what? 2 power 1. So negative 1 square, this will make what? Negative 1 times negative 1. Okay? And then here we have over 2. So it's the second term of the sequence. Negative 1 times negative 1 is positive 1. So it's positive 1 over 2. That's the second term of the sequence. Do you enjoy the beauty of higher engineering and scientific mathematics? Please tell me in the comment section there because I want to get the feedback from you. You know, I'm electronic engineer. So in electronic engineer, we have feedback system in analog electronics. So I like to get the feedback from you. In case you have any questions, please don't hesitate to ask in the comment section. Just let us interact in the comment sections there, right? Okay? I believe that you're going to do so. So that's the second term right now. So let us, because we've been asked you to find few terms, so let us find at least, how many terms would you like? I think that let us find four terms. So the first step, just find what is the steady term of the sequence. So the set term of the sequence, now we say when n is equal to 2, right? So we come back into our general forms of the sequence, which is negative 1, then 2 plus 1, and then we have what? We have against there 2 power 2. So in this sequence, we say that we have what? Negative 1 power 3. Then here we have 2 power 2. So 2 power 2. So simply, if we open this bracket, is -1 times -1 times -1, and here we have 2 times 2. So simply say that the third term of the sequence, this is equal to what? This is equal to -1 of what? Over 4. Wonderful. Then we go for the fifth step. The fifth step say that let us find what? Let us find what? Let us find the fourth what? The fourth, here let us find the second term, of the sequence, first term of the sequence. First term of the sequence. So to find the first terms of the sequence, here when n is equal to 3. So then we come back to our sequence. We have -1 or 3 plus 1 of what? Over 2 or 3. This is equal to what? So we have our curly bracket, we have -1 or 4 over 2 or 3. This will make what? -1 times -1 times -1 times -1. Then we divide this with 2 times 2 times 2. So then we say that the first term is equal to what? So if you multiply this one, you get +1 of what? Over 4. Right? No. Over 8, excuse me. Over 8. So right now, according to the question, write down the first few terms of the sequence below. So now I can write, because there are 4. 4 terms. 4 terms are few. First few what? Few terms of what? Of the given sequence. Do you enjoy the beauty of sequence, infinite sequence? We are learning this sequence in a different way. We taught you sequence for the first time during your Form 3 studies, right? Or Class 11 studies. And then we just introduced the concept of sequence. But later we taught you a little bit about sequence and series during your Form 5 educations or during your ordinary diploma education. But now, in undergraduate, we take it into the next level. Okay, so then we say that the sixth step now, say the write a sequence. Write a sequence. So write a sequence. To write a sequence, we can say that, all right. So you can write, we can say that, okay? So you can say that the nth term of the sequence, that -1 power n plus 1 over 2 power n, when n starts from 0 to infinity. This will give us what? The first few terms. The first term was what? 1, -1, comma, because this is the sequence, it's not series. Don't confuse with series. Then the third term is what? -1 over 4. The first term is what? 1 over 8. What do you think if you want to find the last term? Okay, the last term. So you have this part. So you just have of this one. 2 power infinity. This is going to be a very large number. You get 1 power infinity plus 1, so you get 1 power infinity. You get 1 power, very large number. So you can find that you get infinity over infinity, which is what? Undefined. So simply, this is the response for that question. Okay? Okay? You see the beauty of infinite sequence? You see the beauty here? Is it beautiful? Yeah, mathematics is beautiful, and especially high engineering and scientific mathematics. Excuse me for my voice today is not in its well-defined state, but don't worry, because it will recover soon. So then, ladies and gentlemen, let me present to you a next example, which is example 3, and see what is going on before we take you into the next concept. And this one, all of these examples are from the coordinate of Udom. So again, the question still asking us to write down, let me give you another sequence, write down the first few terms, each of the following sequence. Each of the following sequence. So you have B subscript of N, and you have curly bracket, N is equal to 1 to define it. Where B subscript of N is equal to nth digit of pi. Nth digit of 40 of pi. And this one we can enclose it also in curly bracket. Write down the first few terms, each of the following sequence. So you have B of N, okay? Where B of N is nth digit of 40 of pi. So if it's nth digit of pi, then we say that B1 will be equal to pi, B2, so see? So solution. Okay, solution. So solution, we say that our nth term of the sequence is B subscript of N. So then we say that to get the first term, so the first term when N is equal to 1, because that's the starting point. So this will give us B1. To get the second term, when N is equal to 2, this will give us B2. To get the third term, when N is equal to 3, this is B3. To get the fourth term, when N is equal to 4, this is B4. Okay? That is B4. So this is also the few terms. So therefore, we say that curly bracket of Bn, and then we say that this is N is equal to 1 to define it. This is equal to what? B1, comma, B2, comma, B3, comma, B4, comma, dash, dash, dash. So this is open bracket. Then you're done. Okay, so what can we notice from this process that we've been doing of finding the first few terms of the sequence? It means that we can one of the things that you can notice is we can define the nth term of the sequence as the function, right? As the function, where we have the dependent variable and independent variable. The dependent variable is an, it's the nth term. That's the dependent variable. And then the independent variable is the n itself. So that means a challenge, which means you have to think differently a little bit about what can we notice, what can we realize. Okay? So we say that in the previous 3 examples, we were treating the sequence, we are treating the formulas, of the sequence we are treating the formulas of the sequence as functions. We are treating the formulas of the sequence as functions that can only have integers, integers plugged in. That can only have integers plugged into them. Into this formula. Okay? That's a very important key point. Plugged into them. For example, if you recall the first formula of the sequence, which was n plus 1 over n, so we say that when n starts from 1 to infinity. So this is the formula, but we can define it as what? As the function. Because why you can define it as a function? A single variable function, it just needs 2 information: independent variable and dependent variable. So for this case, independent variable is these integers, which we call them the counting index. And then the dependent variable is this value of what? It is still the value of n, but in what? In the n stems, which sometimes that in sequence we call the an, bn, or whatever. So this we call the n stem, right? Because in the normal sequence of form series, we use called the an, a subscript of n. That's the meaning of n stem. So before we write that, we say that n for instance, that is equal to 1, 2, at integer 3, 4, dash, to what? To Mr. dash, to infinity, right? So this one is what? Is independent variable 40 of the form of the sequence. Okay? And then what you have inside the curly bracket is what we call in mathematics the n stem. Okay? The n stem. So that n stem, we define it as what? The dependent variable. So we say that the n stem, which you can define, depends. A of n, we can define as a capital N independent, B of n, or whatever. So the n stem, an, for instance, let us define as an, which is n plus 1 of what? Over n. So this now, this n stem depends on what? On n. So you say that the n stem, a subscript of n, is what? Is dependent variable. So because we have independent variable of the sequence and dependent variable of the sequence, then that's why that we can define, or we can express the formula into the function, because a function, single variable function, we just need two variables, dependent variable and independent variable, right? So if that's the case that, for example, recall that if you want to write a certain function, let's say f of x, a linear function, is equal to ax plus what b, but these are the constant. So mean that also this one we can write as y is equal to ax plus b. So in this case, or we can even have, let's say that y is equal to 2x plus 4. So in this case, x is independent variable, y is dependent variable, right? So if you compare with what we have in this sequence, in this n stem of the sequence, y is equivalent to the n stem. Y is equivalent to the n stem. It's just like here, y is equivalent to n plus 1 over n. X is equivalent to n. So x is equivalent to n. So for that case, what you say that this f of x or the functions y depends or not on the x. So for that case also we say that we can also define now. So it means that having this n stem like that one, we can define. So remember that we have n stem for our first case is n plus 1 over n. So you can define this as f of n when this one is n plus 1 over n. So it means that the function of of n. So this is the function right now. And this is very important because we are going to deal with these cases. So you have to follow along. You have to concentrate. So again, we had another sequence where we had this -1 power n plus 1 over 2 power n, and hence from n is equal to 1 to infinity. So the n stem here, let's say an, or let's say that the n stem, so let's say capital An, this is equal to it, -1 or n plus 1 of 2 power n. So this is the dependent variable, this is the independent variable. So simply this one, because another function, let's say g of n is equal to -1 or n plus 1 over 2 power n. Because soon we are going to discuss about limits, and before we discuss about limits of limits of the sequence, we are going to graph, to sketch the graph of the sequence. So when you sketch the graph of the sequence, in most cases you should have a function. That's why that we are relating the n stems of the sequence and the functions that we know in mathematics. Okay, so after having that concept now, we can go to the next concept that okay. So he said that the idea, so he said that very important. This idea of expressing our formulas as function, idea of expressing formulas of sequence or series as function is very important. It's very important. Okay, it's very important to do many things in sequence. It's very important to do many things in sequence than we can do otherwise. that couldn't do otherwise. That couldn't do otherwise. So that's the concept that you have to remember. So this idea of expressing formulas of the sequence or series, it can help us to do so many things in what? In sequence and what? And series. Sequence or series. That here we're discussing about sequence. So before even we go further of this infinite sequence, ladies and gentlemen, let me introduce to you about graphing of sequence or graph of sequence. Graph of sequence. Say graph of sequence. How can you sketch the graph of a certain sequence in maths? You have never heard about these concepts in your fundamental and even intermediate learnings of sequence. So graphing the sequence, to graph the sequence, to graph the sequence, let's say AN or A subscript of N. We plot the points of what? N, AN as N ranges. As N ranges over all possible values on the graph. As N ranges over all possible values on a graph. So to graph the sequence AN, we plot the points N, AN as N ranges over all possible values on a graph. What does it mean? Actually, when we be given the functions, the normal functions like this one, f of x is equal to 2x plus 4. If you wanted to draw the graph, if it's a straight line like this one, you can just find x-intercept and y-intercept and then we sketch. But in case it's quadratic or it's cubic functions or other rational functions, or maybe it is composite functions, or it can be step function, or it can be exponential function, then we have first of all to sketch or to draw the table of values. So that's what he said, that to graph the sequence AN, means that this is the n stem. We plot the points of N, AN. Remember that N is certain independent variable, and A subscript of N, which is the n stem, is what? Dependent variable. So as N ranges over all possible values on a graph. So it's sketched. For instance, means if you want to sketch from N is equal to 1 to infinity. So this is the range of N. So this range of N can give us a definitions of 40 of the n stem, right? So, ladies and gentlemen, if that's the case now, we say that so this is example 4. Okay, example 4. Sketch the graph of the sequence that gives in this form n plus 1 over n, then curly bracket, from n is equal to 1 to infinity. Okay, sketch the graph of the sequence. That was solution. So to sketch the graph of the given sequence that like this, we say that okay, so you have given us there. So you have to understand what is our first step. Yes, this is for the matter of understanding. Identify what? Identify independent variable, right? So independent variable, for this case, it's what? It's n. And the dependent variable for this case, it is what? A-n, or the n step. So that's all. So it means that for this case, our first, it is 1, n is equal to 1, and then it goes to infinity. Then our a-n, this is a function that it's n plus 1 over n. The second step now, in order for us to sketch the graph, okay, then we have to draw what? Draw the table value for some values, table of 40 of values. But remember that the value of n is the table of values. The value of n, remember that n is the element of 40. So n, it's the element. So instead of n, is, I forgot the symbol for the element. So n, it's element of 40 of the positive integer. How did I write the symbol for? Yeah. And it's the elements of positive integer. So n is the elements of positive 40 integer. So draw the table for the few values of 40 of n. Means that suppose you have few values of n, and then we can find some few values of 40 of an. So here we have n, here we have an, which is equal to n plus 1 over n. The first value of n, it's what? It's 1. Then substitute it there, you get what? It's 2 over 1, which is 2. Then the second value of n is 2. Then substitute 2 plus 1 is 3. 3 of 40 over 2. Then the next value is 3. Value of n. Next integer. Substitute here. So it will be 4 over 3. Then the next value is what? Is 4. Substitute there. So you get 5 over 4. Then the next value is 5. Substitute there. So you get 6 over 5. Then the next value is what? Is 6. Substitute there. So you have 6 plus 1 is 7 over 6. The next value is 7. Then there we have 8 over 7. Next value is what? Is 8. Then you have 9 over 8, etc., etc., etc. So after having that table value, now we can sketch what? The graph. Before we sketch the graph, we can predict the nature of the graph from these values. This is 2, this is 1.5. This is a certain value less than this one. So you find that the value actually that is, okay, so this is 1 point something, this is 1 point something, 1 point something, 1 point something, 1 point, but this is getting smaller and smaller, so the largest value is what? Is 2, right? That's the largest value. Okay, so it means that the values of n stem are getting smaller and smaller and smaller and smaller. Because this is, I say 2, this is 1.5, this is what 1.3333, this is 1.25, this is 1.22, you see, this is 1.21, 1 something, this is 1.14, etc. So it means that you find the value of the n stem of the given sequence is getting smaller and smaller and smaller, right? So that's the concept that you have to remember. Again, if this is the case, we say that, okay, well, let us keep on moving. Then we say that we have our table of values, and then we say that, okay, so you can sketch now. If you sketch, first of all, because the independent variable, which is n, is limited to have positive integer, so you don't expect to have any graph on the negative side of x-axis. But also, according to the nature of this n stem, right? The n stem, also the n stem, all of them are positive. So we are going to use only the first quadrant of the xy plane. Okay, the first quadrants of xy plane. Okay, xy plane. So this is 0. Okay, so that is. So this one, this is n. And this is a n stem. Right? So we have 0. And then suppose that here we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7. Okay? So then in case of this side, we have what? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7. Okay. So this is the n-axis and this is an axis. So it starts. When value of n is 1, the value of an is 2. So it is here. Okay? It's just here. And then when the value of n is equal to 2, the value of an is 1.5. So this is the coordinate. Okay? Then we say that when the value of 40 of n is equal to, okay, and the value of n is equal to 3, the value of 40, the value of an is 1.333. So it's somewhere here. Then when value of n is equal to 4, the value of an is 1.25. So 1.25. When the value of 40 so we say that when the value of n is equal to 5, value of an is equal to 1.2. Then we say that when the value of n is equal to 60, this is equal to 7 over, it is 1.16. When the value of n is equal to 7, then it's 1.214. So this is actually the sketch, but you find that all of these values, they should be less than 1. Okay, it should be less than 1. So how about the value of an here? How about the value of an? It means that this goes to infinity. Remember that the value of n goes to infinity. How about the values of n there? So we don't know if it will touch the graph or not. We don't know that, how we can. So we don't know. So actually that we have to join these points. Okay? So that's the graph I can be looking for. So it's the end of the graph here. The graph is just going down until it reaches, when n reaches to infinity, you find that the value of an is approaching to 0. So this is figure 3.1. So stated, we take it as the graph of an against the n. So what can we deduce from that graph? What can we deduce from that graph? So from that graph, we can deduce that so we say that from figure 3.1, we can deduce an important idea. And this important idea is the value of n increases as the value of n increases, as the value of n increases from 1 to infinity, then the value of nth term, which is an, is getting closer to 0. It's getting closer to 0. That is. So as the value of n increases to infinity, the value of an is getting closer and closer to 0. What does it mean? It means as we go down, you'll find the value of an is approaching 0. While the value of n, this one actually is approaching to infinity. That's the case. So from here, you know what we can deduce as mathematicians now? From this fact that we had graphically and even also algebraically, right? You know what we can deduce? So then it means that we can now find the limits, we can deduce the limit of the function. Remember that the function we are talking in sequence come from what? The general formula or the n stem, the formula of the n stem of the sequence. So now it means you can reduce the limit. Okay, so we say that with this fact, we say that due to this fact, we can deduce the limit of the function. Now we are speaking about function of the function ffn as n approaches to infinity. So what does it mean? So right now you can say that the limit of the function ffn, okay, as n approaches to infinity for this case. So but we say that ffn for this case is equal to n plus 1 over n. Well, so now mathematically you can say that limit as n approaches to infinity of n plus 1 over n, graphically we saw the limit is equal to 0. You see how mathematics related right now? Yeah, it's interesting. Okay, so that is what we can deduce as mathematicians. Okay. So we say that with this fact right now means, remember that I say that we can say from that fact, which is graphically limit at n approaches to infinity of the function. Let's say we can start with the n stem, which is the formula of the sequence. This also is similar if it defines this as limit as n approaches to infinity of the function of n, and also this is similar if you say that limit as n approaches to infinity for this case of the functions itself, which is n plus n. It means n plus 1 is equal to over n, and this is equal to 0. So we've already discussed with you that we can define formulas of the n stems of the sequence as what? We can define the n stems of the sequence as what? As functions, right? So you say that this notation is similar to the notations of the limits of the function. Okay? So because we have discussed about relationship between the n stem of the sequence and the function, so nothing is surprising to you. So it means that this notation of limit of the function, right, of the sequence, let's say of the sequence is the same notation to the limit of the function, which is single variable function. That depends. So this notation, which notation? This notation of the limit of the sequence is the same as the notations notations of 40. The same as the notations of the limit of the function. The same as the notation of the limits of 40 of the function. Alright? So from this fact, so you see the relationship between sequence and function, and now we are discussing about limit, you see? So first of all, we showed this relationship between the sequence and function. And as once you have a function, we can talk about the graph of the function. And once we have the graph, we can define also the limits of the function. But when you define the limits of the function, remember that function has been deduced from the sequence. So we are still talking about infinite sequence. So this is the end of lecture 3 that titled as what? Limit of the functions, limit of the sequence, and graphing of the order of the sequence. However, that we didn't finish the case now, or the one or the part of this lecture 3, that's limit of the sequence. In the next lecture, that will be lecture 4, I'm going to teach you, because in this lecture I've been convincing you that the limit of 40, we can define a sequence as what? As a function. We can also graph a sequence, and also we can define the results or the outcomes of that, or the outcomes of the graph by using what? By using limit, okay? Or by using the limits. So it means we can define it, we can limit it. It means we can limit some values of the n and the n stems, so that we can at least define the values. Okay? So that's what I've been discussing, what I've been convincing you in these sessions, and will introduce to you the new concept that also a limit of the sequence can either exist or cannot exist. It depends to the type of the sequence which you've been given. So here in this lecture 3, I've been introducing you about the limit, but I didn't teach you about the limit of the sequence. Join me in lecture 4. I invite you right now, so that I'm going to teach you in details about the limit of 40 of the sequence, and we'll see that the way that we are going to define is very interesting. And also later on, you find that when we'll be keeping on learning about the limits of the sequence, we'll find convergent sequence and divergent sequence. That's our target. So convergent sequence and divergent sequence. So converging sequence and diverging sequence, right? So that's very important concept in applied mathematics. So this is the end of this session. I thank God, first of all, who have created me in his own image and likeness. And I thank God who have built the gift of teaching in my heart, because it's the work of my heart. As height has beauty, they're flying for within or inside the birds, because have you ever seen birds attending the flying schools? No. So it's similar to me. So this the gift of teaching has been built in my heart as very important gift for the rest of my life. So I thank him who have prepared me, and I thank him who have given me the energy and the strength to teach you and the wisdom to teach you. I believe that I've transformed you from one point, and I believe that you have understood what I've been teaching you. Please give me the feedback in the comment sections below. But I think that I should leave the homework. Yeah, okay. So let me forgive you. I'll leave the homework in the next session. Okay. So please ask questions. Give us the feedback, whether you understand, whether these contents are helpful for your life, in the comment section. I guess we asked you that make sure that here, if you are watching your video, here you see a button, software buttons that is written subscribe. We are going to have more than 700 high definition videos of teaching you about higher engineering and scientific mathematics. So we are going to post them in our YouTube channels that called Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAI. So for you to get notifications, because we are adding at least one video in a day in our YouTube channel, please click this button for subscribe. So click it. Once you click it, the channel will click. So you click this one, then the bell will appear. Then click this bell. Here you'll see options, 3 options. All, and the other one is personalized, and the other one is none. So I ask you that to choose the options of all. You'll get all the notifications once we add them for you to go through those contents. Again, I ask you that to share, because this is it's a national program. I'm a national teacher of higher engineering and scientific mathematics, who dedicating my life on these programs right now, and I've sacrificed so many things. So I really ask you that to share these contents with your classmates, your colleagues, with your institutions, mate, with your college mate, with your university mate, with your previous advanced mate, with your previous O-level mate. So please share these contents as well as you can. so that hundreds and even millions of the undergraduate students can get help without too much of hassle, because I am the one who have been experiencing those hassles on your behalf. Lastly, but I ask you that also, in case you feel from your heart that you want to offer God your free willing thanksgivings or any days of the offering for what He has done to you in your life, especially that for bringing these programs to you in your hands, in your handpicks, in your mind, without you paying any amount of money, without you paying any piece of coin, of Tanzanian coins, or any piece of US dollar to me. These materials are worthy. I could even sell them so it's actual a reasonable price. But God has asked me to offer a free willing thanksgivings for to Him. I have to offer to Him my gift of teaching, my investment into my initial investment for these programs to have all the electronics equipments that are essential. In order, just I have to offer through the Tanzanians and even other students worldwide. But He gave me a permission to invite you to offer your free willing thanksgiving in order to make sure that the running cost for these programs is well covered without any too much of hassles. So please send your free willing thanksgiving through 0759745331, because remember, I want to tell you, it's very expensive. There's a high running cost to make a single video to reach to you whenever that you are. That's the truth that I want, because I'm a video creator. So because I'm a video creator, I know that it's very expensive, and I'm doing it day after day. So there is a high running cost for this program and also for the entire project. So we know that we can, but remember, the sponsor of Online Undergraduate Polytechnic Institute of Tanzania, in square bracket Olenjolaim, it's not Olenjolai, it's not members of my family, it's not my mother, it's not somebody else, but the sponsor is my God, who is the King of the kings, God of the gods, is the one who is the sponsor. So we don't worry anything else, because everything is going to be settled as well as possible. So in case you want to do the bank transactions, just go to the descriptions, you'll see the bank account, the bank name, and then send your free willing thanksgiving. And believe me that once you send, please send us a message through this telephone number that, and you mention your name, where are you come from, and then so the purpose of this offering, and what are you asking God to give you or to reward you after He has received your offering through Online Undergraduate Polytechnic Institute of Tanzania. So, well, I'm always praying for my online students. I ask you also to pray for me. So this day, let me just give you a chance to continue some other responsibilities. And this is the end of our sessions. I invite you in the next session. I'm always praying for you, and I ask you also to pray for me, so that God can give us commitments and good health and even long life, so that we can do His work as well, that we are alive. May God bless you until we meet with you in the next session.